All right, so now we want to go back and take a look at a definition. If f is a function and r is a real number such that f r equals 0, then r is a real 0 of f. The following are equivalent. R is a real 0 of a polynomial function, and r comma 0 is an x-intercept of the graph of f. X minus r is a factor of f. All right, so let's kind of digest what that means. So if I know that, for example, 5 is a 0 of f. Let's suppose I know that. That means 5 comma 0 is an x-intercept, and it means that x minus 5 is a factor of f. And so if I know one of these is true, then the other two are true. The power m on the factor of x minus r is called the multiplicities. Thus we say r is a 0 of multiplicity m of f. For the function f of x equals x minus 3 squared times x plus 2, negative 2 is a 0 multiplicity 1, because my power here would be 1, of f, and positive 3 is a 0 multiplicity 2 of f. And then this leads to a theorem. Let r be a real 0 of polynomial function f of x with multiplicity m. If m is even, the sign of f of x does not change at x equals r, and the graph touches or bounces on the x-axis at x equals r. If m is odd, then the sign of x does change at x equals r, and the graph crosses the x-axis at x equals r. So for example, let's say I were to take my parabola y equals x squared. I have a 0 at 0. And notice here, since my power is even, my graph touches. It does not go through the x-axis. It touches, it bounces. That's because my power is even. If I were to look at the x cubed function, now my power is odd, so notice it crosses through at that 0. So let's go into the workbook, and let's go ahead and try some problems. So remember, the value of x in the domain of f for which f of x equals 0 are called the zeros of the function. These are real solutions or roots of the equation f of x equals 0 and correspond to the x-intercepts of the graph y equals f of x. And it looks like we got an extra space there, so let me just circle that so that way I can fix it later. So we are determining the zeros of the function defined by f of x equals x cubed minus 5x squared minus 16x plus 80. So basically what we're doing is we're solving x cubed minus 5x squared minus 16x plus 80, saying that equals 0 and solving. Now we know how to do that from before. We go through and factor. And here I got 4 terms, so I want to factor by grouping. My first 2 terms have a common factor of x squared. My leftovers are x minus 5. My last 2 terms have a common factor of 16, but I want to take out a negative there. Oops, wrong color, my bad. That gives us x minus 5. And now looking at our 2 pieces, they have a common factor of x minus 5. So I'm going to bring that out in front. My leftovers are x squared minus 16. But now Well, actually, there's kind of two ways we can go here. One way, I can say this is a difference of squares. So I would factor into x minus 4, and so x plus 4 times x minus 4. And then, well, if x minus 5 is a factor by my theorem, means x equals 5 is a 0. And where you would get that is you're literally setting this equal to 0 and solving. Similarly, if I take x plus 4 equal to 0 and solve that by subtracting 4 from both sides, you get negative 4. And likewise, I'm going to get positive 4 for the last factor. So that's one way to approach it. The other way to approach it is we set that x minus 5 equal to 0, and then the x squared minus 16 equal to 0. This still gives you the same thing, x equals 5. This one I'd add 16 to both sides, and then when I use my square root property, I'm going to get x equals plus or minus the square root of 16, which is 4. So notice, either way, I get the same solutions. So my zeros are negative 4, 4, and 5. Alright, so, and then for this next one, they remind us a polynomial function has a factor of x minus c that appears exactly k times, then c is a 0 multiplicity k. So that's just reminding us about the multiplicity. So number 4, excuse me, it says determine the zeros and their multiplicities for f of x equals 8x times x minus 1 squared times x plus 3 cubed. So I'm going to first look at the 8x. 8x equals 0 gives me, dividing both sides by 8 gives me x equals 0. And that'll be of multiplicity 1. Second one, x minus 1 equals 0. Add 1 to both sides, that gives me x equals 1. Now my power here was 2, so that's going to have multiplicity 2. And then this last one, x plus 3 equals 0. My corresponding 0 would be x equals negative 3. And it's going to have multiplicity of 3. So what should happen if I were to graph this thing? At x equals 0 and x equals negative 3, the graph would go through the x-axis, cross through. But at x equals 1, it would bounce. Here go like that, or maybe like that. And what effect do the multiplicity of zeros have on the graph? Know how the leading term changes the behavior. So here you notice here that each of my powers here are 1. They're odd, and notice that the graph crosses at x, at each x-intercept. Here it's odd at 0, odd at negative 3. So notice that at 0 and negative 3 it crosses. But at x equals 1 it touches because my power is even. So this should be cross, cross, touch. So notice cross, cross, touch. So if C is a 0 of odd multiplicity and the graph crosses the x-axis at C, if C is a 0 of even multiplicity, then the graph touches the x-axis at C. So here we're given f of x equals negative 3x squared times x plus 4 times x minus 7 cubed. And we want to identify the zeros of the function and where there is a cross point or touch point at each 0. So the first one I want to look at is this one here. So that will give me a 0 of x equals 0. My multiplicity, oh, my purple's dying on me. So it'd be a multiplicity of 2, that's even. So that's going to be a touch. So that's going to be a touch point. It's going to touch. Next one we want to look at is x plus 4. That's going to give me a 0 of x equals negative 4. That's going to have a multiplicity. Again, I'll just abbreviate. Though it would help if I put the letters in the correct order. It's going to have a multiplicity of 1. So that should cross because it's odd. And the last one is x minus 7 cubed. So I'm looking at this one now. So that'd be x equals 7. It's my 0. That's going to have multiplicity of 3. That's odd. Since that's odd, it's going to cross. So that'd be a cross point.